now we try to find the area of the largest rectangle that can be inscribed in the upper half of the ellipse x squared over 36 plus y squared over 4 equal to 1. So here's the ellipse. I plugged in 0 for x and I saw for y that those gave me y-intercept. Plugging in 0 for x gives me y squared is equal to 4. Therefore, y is equal to negative 2 and 2, and plugged in y equal to 0 to find the x-intercepts, and those were negative 6 and 6. Now, if I'm inscribing a rectangle, it will look like something like this, and so there are 2 points, 2 symmetric points on the oval, and then 2 other, these are 2 vertices of the rectangle, and the other 2 vertices are going to be sitting on the x-axis like this. In changing x and y will change the area of this rectangle, because it symmetrically changes all the other vertices basically. Now, my question is, how do we go about this? When it comes to optimization, a rule of thumb is that to take whatever function you have, first of all, find what your objective function is, then take that objective function, use a constraint to make that function of one variable. So what is the objective function? As I'm reading, I can see that the objective function is the area, and the constraint is that point on the oval. One way to describe the constraint is to parameterize the points on the oval, because this could be any points on the oval in the first quadrant. Best parameterization of the oval basically involves setting x squared over 36 equal to cosine squared theta, and y squared over 4 equal to sine squared theta. And from there you get x is equal to 6 cosine t and y equal to 2 sine t. And that's the good parameterization. And then objective function is obviously the height is y in here, and the length is, here is 1x and over here is another x, and so 2x, so 2xy is the objective. Now create the objective function in terms of one variable and replace by replacing x equal to 6 cosine t and y equal to 2 sine t, and you get 24 cosine t sine of t. We need to use a trig identity because I don't know what the maximum of sine of t times cosine of t is, and so I use a trig identity, and that is sine of 2t equal to 2 sine of t cosine of t, and the function becomes 12 sine 2t. Now from here, because sine 2t is maximum when it's 1, I can say that and the entire thing, the maximum of the area is 12, and it's maximum when 2t is equal to pi half. And so solving for that, sine of 2t equal to 1 gives me the maximum, that is 2t equal to pi half and t equal to pi fourth, and pi fourth is in the domain. What is the domain? You want to assume, because you picked the x and y to be in the first quadrant, t only can go all the way to pi half. So t is between 0 and pi half. Sometimes include sometimes this is an open parenthesis. And so the dimensions are going to be, again, you found t, you have to plug it back into x and y. X was 6 cosine of t, y was 2 sine of t. If you plug them in, you get 6. For x, you get 6 over square root of 2, and for y, you get 2 over square root of 2. And remember, this length of the rectangle was 2x, so 2 times 6 over square root of 2 is the width, and the other one is the height, and you found the dimension of the rectangle.